Good morning everyone. Data mining PowerPoint presentation. So in this PowerPoint presentation we are going to see about multimedia data mining and it's follows. Multimedia database is the collection of interrelated multimedia data that includes text, graphics such as sketches, drawings, images, animations, video, audio, etc. and have vast amount of multi-source multimedia data. The framework that manages different type of multimedia data which can be stored, delivered and utilized in different ways is known as Multimedia Database Management System. Moving on to the next slide, similarity search in multimedia data. There are two types of multimedia indexing and retrieval system. They are descriptor retrieval system and content-based retrieval system. Descriptor retrieval system is a root of image content-based retrieval system and it is represented by multidimensional vectors of real numbers and it encodes specific information extracted from an image. It is invariant to some types of variations. Next one is content-based retrieval system. It is the image processing techniques to extract descriptors from images, that is large grain recognition, color histogram, gray level histogram and fine grain recognition and local descriptors. Database techniques to store descriptors and accelerate searches like dimensional curves and pyramid tree and PA file. Content-based retrieval system is an important research area and it is challenging problem since multimedia data needs detailed interpretation from pixel values and different strategies in terms of semantic and semantic indexing for in content-based retrieval system, there are two kinds of queries such as image sample-based queries and image feature specification queries. Image sample-based queries include search compares that the feature vector is extracted from the sample with images and indexed in image database, and images closer to the sample images are returned. Image feature specification queries include sketch image features like color, texture or shape and it is translated into feature vector to be matched with the image database. Then it is using different kind of application like medical, weather, web search engine for images, etc. Then it supports both sample based and image feature specification queries, and it also supports color histogram based signature, multi-feature composed signature, wavelet based signature and wavelet based signature with region based gradient. Moving on to the next slide, wavelength based signature. It uses the dominant wavelet coefficients of an image as its signature and these wavelets captures shapes, textures and location information in a single unified framework and it improves efficiency and reduces the need for providing multiple search primitives, and it may also fail to identify images containing similar objects that are in different locations. Then wavelet based signature with region based granularity. In this approach, the computation and comparison of signatures are at granularity of regions and not the entire image. And similar images may contain similar regions, but a region in one image could be a translation or scaling of a matching region in the other. And it also computes and compares signatures at the granularity of regions and not the entire. Multidimensional analysis of multimedia data. It includes multimedia data cube such as design and construction similar to the traditional data cubes from relational data, and it contains additional dimensions and measures for multimedia information such as color, texture and shape. The database does not store images for their descriptors. For example, in future descriptors, a set of vectors for each visual characteristics or color vectors that should contain the color histogram, and MFC, that is most frequent color vector. It includes 5 color centroids, and MFO, most frequent orientation vector. It must include 5 edge orientation centroid. And in layer descriptor, it contains a color layout vector and an edge layout vector. Moving on to the next slide, multimedia data types or the types that includes any type of information medium that can be represented, proceeded and stored and transmitted over network in digital form, and multilingual text, numeric images, videos, audios, graphical, temporal relation, and categorical data, and its relation with conventional data mining term. The above diagram represents the output of the classifier module of multimedia miner. Moving on to the next slide, that is advantages of multimedia mining. It is very user friendly. It doesn't take much energy out of the user, in the sense that you can sit and watch the presentation, you can read the text and hear the audio, and it's multisensorial. It uses a lot of user sense while making use of multimedia. For example, hearing, seeing and talking. It is integrated and interactive. All the different mediums are integrated through the registration process, and its interactivity is heightened by the possibility of easy feedback. It is flexible. Being digital, this media can easily be changed to fit different situations and audiences. It can be used for a wide variety of audiences, ranging from one person to a whole. Last but not the least, disadvantages of multimedia mining. In this, information is overload because it is too easy to use, and it can contain too much information at once, and it takes time to compile, and even though it is flexible, it takes time to put the original draft together, and it can be expensive, and it makes use of a wide range of resources which can cost you a large amount of money, and it takes too much unpractical time, and large files like video and audio has an effect of the time, and it takes your presentation to load, and adding too much can mean that you have to use a larger computer to store the file. And that's all about multimedia data mining. Thank you everyone.